Thank you for joining to our webinar. This is our second edition of the Ignite by Akamas series. And the topic for today would be Pimp My Kubernetes, Make It Cheap and Cool. Today's speakers are Henrik Rexed and Stefano Doni. Henrik is cloud native advocate at Dynatrace. He's been one of the organizers of the Performance Advisory Council conference, and now he's the owner of the YouTube channel Is It Observable, which I'm sure you have knowledge of. And Stefano is CTO and co-founder at Akamas. Stefano has been obsessed with performance optimization and is leading the Akamas vision for autonomous performance optimization powered by AI. What you can expect to get out of this webinar is to better understand Kubernetes resource management, how to improve Kubernetes observability, how to automatically tune Kubernetes settings, how to optimize Kubernetes microservice applications, and how to reduce the cost of running Kubernetes. Well, I think we're ready. Henrik, the floor is yours. Let's start with something different.
All right, thank you for this introduction. So first of all, I'm very happy to be here and to spend this hour with you. And so you were expecting to speak about Kubernetes, but no, we're going to talk about cars. Yes. I mean, I'm a big fan of cars, and yeah, so we can just change topic and talk about cars, in fact. And as a car lover, I'm not a love new cars, but oldies, I would say. And as a car lover, I always wanted to have a DeLorean. I don't know if you know this car, but I guess if you watched Back to the Future, you know that car for sure. So I already wanted to have that car. This car is amazing, very speed, a lot of big, powerful engine, but it has a problem. It's not very so much safety. And the other problem is that it's pretty much expensive to be able to have access to that car. So instead of buying this DeLorean, I end up buying a Volvo. So Volvo, okay, so I don't have the same engine for sure. That's true. But at least this car is safe. It's robust. It's impossible to break it. So, okay, yeah, I don't have the coolest car of the world, but I have the safest car and the most reliable car. And in fact, for Kubernetes, it's a bit the same thing. If you pay attention, Kubernetes could have various type of engines. So you have a couple of engines that are pretty cool, but not very well configured. And as a consequence, you end up running, driving a Pinto, a Ford Pinto. If you don't know, I would recommend to Google it. You end up with a Pinto, and as a consequence, you get an accident in the highway, and it's a disaster. And with Kubernetes, it's going to be the same thing. You can end up with a big disaster in production environment because you never thought about configuring it. So I would prefer to reconfigure it and change my Volvo into a P1800, which is a great model, by the way, which is nice and safe and runs smoothly. So when it comes to car, we at least goes once a year to our garage to make it sure that everything that is in our engine is working fine. And why don't we do anything like this on Kubernetes? I don't get it. In fact, if we look a bit further, Kubernetes behaves a little bit like an engine, a car engine. So, you have the V, the W, or A12, whatever the number of engines. But in that engine, you have pistons. And those pistons allow your car to basically move and get power. And the pistons, move. There's a chamber for explosions. And this explosion gives you the speed, the power, and everything. So if we compare it to Kubernetes, the piston will be the pod. And the chamber, the size of the chamber will be the configuration that you have applied in a cluster. So I don't want to configure those pistons by myself because there are great engineers doing on the automotive industry. But in Kubernetes, we have the freedom to change every pistons we want. And that could turn into a disaster if we don't know what we're doing. In fact, the there is a reflect. Here is a link, by the way, with all the Kubernetes horror stories. Those horror stories come from a presentation delivered by a huge, well-known brand of the industry who shared their horror stories during KubeCon. So there is one delivered by Airbnb, by Zalando. There's many of them. So I will let you at least discover those horror stories after this webinar. But keep in mind that there are a few other stories about performance issues where a lot of latency has been increased, response time has increased, a lot of CPU throttling behind the scene that was happening. And on the other way, you can also have a lot of stability issues where the workload has been killed by Kubernetes through OM kill events. And that was basically make the application not available during a few seconds. So I love Kubernetes, but I would prefer to drive a Volvo Kubernetes engine than a Pinto Kubernetes engine. So how can we optimize this? Let's see that. Let's wait a few seconds and we will see this in 2 seconds.
Thank you, Henrik, for your introduction about Kubernetes. And we have a question for you, the audience. I'm about to ask you for what is the business challenge today with Kubernetes? Is it about ensuring microservice application performance and resilience, or keeping Kubernetes costs under control, or setting and maintaining container resource requests and limits, or configuring pod auto-scaling settings, or identifying performance bottleneck in microservice application? Please select one or more of the questions. Thank you for your answers. We wait for a few more seconds so that you have the opportunity for filling in. I see the progress. So, okay, we're getting your votes. Thanks you again. Okay, almost all people have answered. Good. Okay, the results are still coming, but I would say there are definitely a couple of winners here. Setting and maintaining container resource requests and limits is high in the ranking, as well as identifying performance bottleneck in microservice application. I think this is a great results and confirms the findings that we receive from customers. So let's move forward. I think it's time for discussing how to improve the observability and optimization of Kubernetes. But first of all, I think Stefano will illustrate some interesting facts about Kubernetes resource management, right?
Yeah, right. So hi, everybody, and thanks for being with us today. Thanks, Henrik, for the great introduction about cars and the challenges in managing performance, cost, and efficiency of Kubernetes applications. So the key question for me really is why it is so challenging. So why so many organizations are struggling with Kubernetes application performance and resiliency. So to really try to answer this question, let's now go back a little bit to the fundamentals and see how Kubernetes really manage our application resources. As we are going to see, the key to achieve high application performance, stability, and efficiency is properly configuring our application to run optimally on Kubernetes. So let's now go through 4 main key facts and their implications. So the first important concept here is a resource request. When a developer defines a pod, she has the possibility to specify resource requests. Those are the amount of CPU and memory the pod, or better the container within the pod, is guaranteed to get. Kubernetes will schedule the pod on a node where the requested resources are actually available. So in this example, pod A requires 2 CPUs and is scheduled on a 4 CPU node. So when a new pod B of the same size is created, it can also be scheduled on the same node. So this node now has all of the 4 CPU requested. So if another pod comes, let's say a pod C is created with the same specs, Kubernetes won't schedule it on this node as its CPU capacity of the node is full. So what does this mean is really that those numbers that a developer puts in a YAML file are really used by Kubernetes to manage real cluster capacity. So a quite surprising fact is that Kubernetes, there is no overcommitment on requests. So you cannot really request more CPU than those available in the cluster. So this is very different with respect to virtualization, for example, where you could create VMs with many more virtual CPUs than what you really had on your physical host. And another very important fact to note is that resource requests are not equal to resource utilization. So if a pull requests are much higher than the actual resource usage, you will end up with a cluster that can be full from a Kubernetes perspective, even though its CPU utilization can be as low as 1%. So setting proper pod resource requests is paramount to achieve Kubernetes cost efficiency. And this is one of the main pillars that we are going to cover here. So let's now move on to the second important concept, which is resource limits. So resource requests are the guaranteed resources that a container will get, but usage can be higher. Resource limits is the mechanisms that Kubernetes put in place to allow you to define the maximum amount of resources that a container can use, like 2 CPUs or 1 gig of memory. All this is great, but what happens when resource usage hits the limit? Kubernetes treats CPU and memory differently here. So when CPU usage approaches the limit, the container gets throttled. So this means that the CPU is artificially restricted, and this can result in application performance issues. Instead, when memory usage hits the limit, the container gets terminated. So there is no application slowdown due to paging or dropping as we had in traditional operating system. So with Kubernetes, your pod will simply disappear and you may face serious application stability issues. There's another interesting effect related to CPU limits and application performance. So CPU limits work by throttling CPU performance, as we had told before. So you may actually think that this happens only when CPU usage really hits the limit. Quite surprisingly, the reality is different. So CPU throttling starts when CPU usage is well below the limit, actually. So we did quite a bit of research in our labs on this aspect, and we found out that CPU throttling can start when CPU usage is as low as 30% of the limit. This is due to the particular way CPU limits are implemented at the Linux kernel level. Actually, it's not directly implemented by Kubernetes. We won't have the time to go into details today, but feel free to reach out if you are interested. So this kind of CPU throttling is pretty aggressive and can have a huge impact on application performance. One of the effects that you may notice is that, for example, you may get sudden latency spikes for your microservices. They may even breach your SLOs without any apparent reason, even at low CPU usage. Now, some people, including engineers at Buffer, tried to remove CPU limits. And what they got was an impressive reduction of service latency, as you can see on the rightmost chart on this slide. So it is a good idea to get rid of CPU limits. So the answer is actually no. Remember, CPU limits exist for the purpose of ensuring that application can run fine and coexist without having performance interferences. So if CPU limits are removed, a single runaway application can completely disrupt the performance and availability of your most critical services. So this best practice is also recommended by Google itself. Properly setting your CPU requests and limits is critical to ensure your Kubernetes cluster remains stable and efficient over time. I guess now it's time for the second pod, Giuseppe.
And here is our second and last poll. Which tools and practices you have in place for managing Kubernetes? Whether you have observability tools only in place in production or in production and in pre-production, whether you do performance testing before releasing, only after production incidents, or proactively on a regular basis. Thank you for responding to the poll. I see results are coming. Waiting a few more seconds. Thank you. I see results. The vast majority has observability tools both in production and pre-production. Most people are doing performance tests before releasing, and also a good number, majority are doing performance tuning proactively on a regular basis. Many thanks.
All right, so let's move on to the second part of this webinar. And the question was how can we manage the configuration? We see it's a challenge, we see it's important, it's a recommendation from Google and everything, so we need to set it up. And you will see it's very difficult to find the right numbers to make your cluster robust and make sure that there's no impact to your end user or to your customers. So that the solution for that is the secret sauce, is the full stack observability by Dynatrace. So giving you the observability on what happens on your cluster, and Akamas to do the full stack optimization. And we'll discuss about it in a few seconds. But of course, if you want to improve the configuration of your cluster, you definitely need to have observability. That's natural. If you're running Kubernetes, there is a lot of things to manage. So if you don't have any of the right level of observability, that could be a significant danger for your users and for any operation task that you may have to handle in your production environment. So in terms of observability to handle the configuration, I would say you need obviously 3 pillars, but I will of course say that we need 4 pillars. To validate the settings, you will obviously need the logs, because your logs will allow us to get a lot of details. But events, as you may know, Kubernetes is generating tons of events in the cluster. So it will be very important to collect those events as well, because that could be a source to trigger any alerts or anything. Last is, not last, but metrics, obviously we used that. There is a lot of interesting information that we can get out of the number of desired pods versus the number of pods running and so on. And last is traces. Traces, of course, here it's more on the app side. But if you know that your transaction has been slowed down, if you know that this transaction is spending most of the time in the CPU, that could be a sign to say, hey, it seems that there is some throttling somewhere. And the great news about that, those 4 pillars, is that if you deploy our Dynatrace Kubernetes operator in any Kubernetes flavors, then you will have everything, all those pillars coming in back in Dynatrace without any effort. So let's see those things one by one. So first, when you have to deal though with validating those configuration aspects within your cluster, there are few indicators, metrics, and events to consider to track those potential issues. So first, as Stefano explained, if you, depending on the settings of your request and limits, you could basically increase the latency, the failure rates of your application. So obviously, the first indicator that I will keep track is the error rates on my critical applications, the response time. So if I see any significant increase, I could also be alerted and see if there's any if the root cause is related to those settings. On the node level, as you mentioned, our workload runs on nodes. So I would be really interested to figure out how my node is currently utilized, how many pods is running there, and also have maybe a vision on how many pods as requested, the total memory and CPU requested by my workload, to basically anticipate if there's any, if I will be running into issues in the future. The second layer would be, the third layer, I would say, is pod. Of course, we define request and limits. So I want to keep track on what has been requested, how is the limit, and how is the usage of my pod in the CPU or in the memory. And if I want to see more details on, especially on the CPU throttling, I won't see it on the pod level because it happens on the container. So if I want to measure if I have any CPU throttling, I need to reach out to the container to get that detail. On the event side, there are obviously 2 different layers that will provide me events, Kubernetes events. And the first one is the node. So if our node is running out of resources, or if there's some specific workload that is over-consuming some CPU, Kubernetes can throw an event called node pressure. So that is also a sign that your node is a bit unhealthy. So you should take actions related to those events. On the pod layer, there are a lot of events that are very useful, but in our particular case related to configuration, fail scheduling is a great sign, because if we are not able to schedule our workload, it means obviously our nodes are pretty much saturated. So there is a sign of something going wrong. And otherwise you have eviction. Eviction is basically an event thrown by Kubernetes. If our node are saturated, Kubernetes will try to protect the node, so he will try to evict. Evict means he will kill the pod and reschedule it elsewhere. So there was an eviction event that will be raised. And last, if our memory limits and requests are not well defined, as Stefano explained, our Kubernetes could kill our pod because it has overconsumed memory. So he will throw EOM event killed event. When it comes to Dynatrace, we have several areas where we can see those elements. And the starting point, the entry point, I would say the unified view on the health of the cluster would be the cluster view. This cluster screen will give you details on the nodes, how the nodes are being utilized in general. So how many CPU has been requested and the limits and so on. So you can keep track on how is your resources on your production or other environment, by the way. And also you can have a look at the workload. How is your workload spread out in terms of Kubernetes objects or in between namespaces, because you can potentially have namespaces that are more critical than the others. And last is events, as we explained, is very important. So I will have the event card that will show me all the events that has been raised by numbers. So I can see the most important events through this event card. Then, of course, I want to probably jump in more details on my workload. That's the reason why I will want to look at the namespace screens or the pod screen. The namespace screen here will remind me the resource usage and the quality of services. So the quality of services, just to remind, from the moment you define a request and limit, Kubernetes will associate a quality of service. There's 3 of them, the burstable, guaranteed, and best effort. And as in the example, you see on the screenshot on the left, there is some question mark. And here is basically, we remind you how is the limit versus the request and versus the usage. So you can keep track if someone has set the requests too high, for example, that could be an efficient way of managing the resources. And so you can keep track that directly from that screen. And last is the pod screen. The pod screen is very important because I can see the usage, of course, but also the response times of the given services that runs on that pod. And if there is a service, Dynatrace services attached to this, then I can jump to that Dynatrace service screen, where I would have, of course, all the diagnosis tools like the pure path, the service flow, the method hotspots, and more. And that's for the Dynatrace support. And there's another way that I would recommend to do when you're using Dynatrace is how can I create alerts based on events? And technically, events in Dynatrace are considered like a bit logs as a log source. So I would basically look at the log screen that we have, put the right filter. I probably want to filter on a couple of events because they will be in your logs. Say the OM kill event, which is a very important event that you can keep track. I create my filter, and then I have the options to create a metric out of that. So once I have to create the metric, I would really take time to define the right dimensions, because dimensions is very important when you want to create alerting or dashboarding, because dimension is a way of helping you to split, to make a query you can split by a dimension or filter by dimension. So once you have the dimensions, the metric won't exist yet because we need to ingest new logs coming in Dynatrace, and then this metric will appear in the screen. So once the metric exists in Dynatrace, I can take advantage of the metric explorer, a lot of different screens to define a query, to create a ratio if I want to create an SLI or an SLO. I can create alerting rules. There's many things you can do once you have a metric, for sure. And the other thing I'd like to share as well is the support of open observability. There is so many framework out there that provide a lot of values and a lot of visions on what happens on our cluster. So it makes sense to utilize it as well. So if you use our Dynatrace Kubernetes operator, this Dynatrace Kubernetes operator has the ability to scrap Prometheus metrics. So I will naturally install the Prometheus operator on my cluster that will bring us a lot of things related to Prometheus, like the alert manager, the Prometheus server, and a couple of key Prometheus exporter. And by the way, the one I was referring related to the metrics that was you should keep track. I will keep CubeSet metrics will give you the behavior of your pods. The node exporter will give you the behavior of your nodes to see the health of your nodes. CA advisor is everything about your container. So if you look at the CPU throttling, you will get it from the CA advisor. And on the last year, I have added the event exporter, which is an open source project that will expose also metrics related to events. So if you want to just throw events metrics, you can do so with that project. So that's the way of doing it with the Prometheus. But if I want, I don't want to use Prometheus. By the way, to take advantage of those Prometheus exporter, you just simply have to put annotations on your workload. So there's specific Dynatrace annotation, and then Dynatrace will scrap all the metrics where you have applied those annotations on your workload. So we don't scrap on the Prometheus server, we scrap directly at the exporter level. And the other thing which we have in terms of support is the OpenTelemetry. So we are fully compatible with OpenTelemetry. So if you want to generate traces in OpenTelemetry format, you can do so, and Dynatrace will be able to pick it up and bring it back to Dynatrace. Or if you want OpenTelemetry, as you may know, is not limited to traces. It's supposed to cover metrics, traces, and logs. Logs is still on a development state. But you can basically, instead of letting Prometheus ingest the metrics, I could basically create a metric pipeline in my OpenTelemetry collector that will get those data and send it back to Dynatrace as well. So both ways are very fine. You have the freedom to choose which one you want to utilize for sure. Over to you on how to optimize your Kubernetes cluster. Everyone is eager to see, now we know how to observe, but now let's see how we can optimize in a smart way.
Thank you, Henrik, for the great content. I think having an effective full stack observability solution is really key to manage Kubernetes microservice applications. So let's now focus on the optimization part. So optimizing microservice applications is really a daunting task today for developers, SRE, and performance engineers, given the complexity of tuning Kubernetes resources, as we have seen, and also the many moving parts that we have in modern applications. So we have lots and lots of microservices that are really comprise modern applications. So this is why at Akamas we invented a new approach to solve this kind of problem. So our vision at Akamas is that only an autonomous optimization solution powered by AI can effectively enable providers of digital services in delivering the best user experience, maximum service resilience at the lowest possible cost, and at an ever-increasing business speed. So our approach is based on 4 key pillars. So the first pillar is full stack, meaning that Akamas is able to optimize several different technologies at the same time. So this is really key to extract the full performance gains from our Kubernetes applications. For example, the optimization might focus on container resource sizing, but not only that, you might also focus at the same time on runtime settings of the application, like the JVM or other application options at the same time, because all those layers are really dependent and interconnected among each other. Second key ingredient is AI. So AI is really the way that for Akamas to explore this smart way, this space of potential configuration, which is really huge. So if we consider all the possible values for all the possible parameters, we really have billions of configurations. So a brute force approach simply is not feasible and will not work for this kind of problem. To be effective, the optimal configuration needs to be identified in a reasonable time frame at an acceptable cost. Third, Akamas allow us to optimize application based on each specific need and use case by defining custom optimization goals. So for example, in some cases, the user may want to reduce the service latency to provide the best possible performance at peak load. And for another user, the cost might be the key driver for the optimization, while perhaps maintaining the current service performance. So last but not least, Akamas optimization is fully automated, which means not only suggesting new parameters using AI, but also applying them to the target system to ensure really a completely automated and reliable optimization process end to end. So let's now see how the optimization process works in practice. So in this figure, we have the Akamas on the left and our Kubernetes environment to be optimized on the right. So the automated AI-driven optimization process works in 5 steps. So the first step is to apply the new configuration that AI suggested to our target application and pods. So this is typically done leveraging Kubernetes APIs. We don't have any agents here. We didn't want to reinvent the wheel. So the second step is to apply a workload to the target so as to assess the performance of the applied configuration. So to do that, Akamas provide native integration with market-leading performance testing tools, both open source like JMeter and commercial ones like LoadRunner and Neoload. The third step is to collect key performance indicators related to the target system. To do that, Akamas provides a native integration with Dynatrace Observability solution, which allows you to measure the key metrics of the entire stacks, including services, language runtime like the JVM, down to the pod and Kubernetes container metrics. The fourth step is to analyze the results of a performance test and to assign a score based on the specific goal that you have defined. It can be the latency or the throughput of the test. So this can be done, is done automatically also. So Akamas also takes care of analyzing the results and identifying the score of your experiment in an automated way. The last step is where machine learning kicks in by taking the score of the tested configuration as input and by producing as output the most promising configuration to be tested in the next iteration of the same process. So this process goes on, and in a relatively short amount of time, the machine learning algorithm so learns the dependencies among the different parameters in the configuration and also the system behavior, how does the system react to those parameters, identifying better and better configurations. Let's now see this new approach applies to a real-world example. So in this demo, we are the target system is Google Online Boutique, which is a cloud-native application running on Kubernetes made of 10 microservices. The application features a modern software stack, including services written in Golang, Node.js, Java, and Python. And it is pretty handy as it includes also a load generator based on Locus, which generates realistic traffic to test the application. This is the overall architecture, how we integrated Akamas into this system. So the parameters that we are optimizing in this example are the one that we have talked about before. So the CPU and memory limits of each microservices. So we have 22 parameters in total that we are optimizing with AI because actually we have 10 microservices plus 1 database. So all those parameters are applied automatically by Akamas leveraging the Kubernetes APIs. In order to assess the performance of the overall application with respect to the different sizes of the container, the different parameters, we leverage the built-in Locus load injector. We then leverage Dynatrace to gather the container and service level metrics to gather pod resource consumption metrics and also service level ones. So the whole optimization process is defined in a kind of within Akamas as we have a workflow concept in there that lets you automate all those steps, and then we press play and the optimization can really begin. So let's state a little bit what is the goal of the optimization. So in our example, we aim at increasing the efficiency of the online boutique application. That is both to increase the service throughput and decrease the cloud cost. At the same time, we want our service to always meet its reliability targets, which are expressed as latency and error rate SLOs. Therefore, our optimization goal is to maximize the ratio between service throughput and the overall service cost. The throughput is measured at the front-end layer where all user traffic is processed. So this is the service that Dynatrace can measure. And the service cost is the cloud cost that we pay to run the application on the cloud, considering the CPU and the memory resources allocated to each single microservice. So in this example, we use the pricing of AWS Fargate, which is a serverless Kubernetes offering by AWS, which charges, for example, $29 per month for each CPU that we request for our containers, and about $3 per month for each gigabyte of memory. Akamas also allows us to set constraints on which configuration are acceptable. So in this case, it's important that we can express as performance engineer that our application should have a maximum 90 percentile latency of 500 milliseconds and an error rate lower than 2%. So that is it. This is the way that we can define also our optimization goals as a performance engineer and software developer in a kind of declarative fashion. And at this point, once we have done this, we can really start the ML, machine learning based optimization, and let it run automatically while we are relaxing and doing some other important stuff. So let's now see what are the results that we got. So in this chart, each dot represents the cost efficiency of the application, which again is the service throughput divided by the cloud cost as a result of the different configuration of microservices, CPU, and memory limits as chosen by the AI optimizer. So the results of our AI-based optimization approach is quite astonishing. So a configuration that improved the cost efficiency by 77% was automatically found by Akamas in about 24 hours. So think about the complexity of doing this manually with 22 parameters and 11 microservices, which is actually a pretty small application for today's standard. So if we look at the baseline configuration, which corresponds to the initial sizing of the microservices, this configuration has a cost efficiency of 0.29 transaction per second per dollar per month, while the best configuration that machine learning found, tuning the microservices resources, actually achieved 0.52 transaction per second per dollar per month. So a pretty significant improvement. What is interesting from this chart is that we can actually understand how our machine learning-based optimization works, and the fact that it learns from each single experiment, each single dot that actually correspond to different parameters that has been tested and quickly converge towards the optimal configuration in a very small amount of time. So at this point, I guess you may want to know what is the best configuration looks like. So let's inspect the best configuration by focusing on the 10 most important parameters. So you can see here, basically, for the different microservices comprising this application, what were the most important parameters. You can see what was the original value before we applied Akamas, which is the baseline, the orange one, and also the best value, the green one. So it's interesting to notice how our AI-based optimization actually reduced the CPU limits from many microservices. This is actually clearly a winning move from a cost perspective, because cost is clearly related to the amount of CPU that we are requesting from the cloud. However, it also automatically learned that two particular microservices, in this case, the product catalog and the recommendation service, were actually under provision. So Akamas AI found that it needed to increase both the assigned CPU and memory of those microservices in order to ensure maximum performance. So all those services changes at the microservice level were critical actually to achieve our optimization goal that we set on the application level, which is to maximize the throughput and lower the cost while matching our SLOs. So it's also very interesting to see what happened at the service level performance. So how does the application performance is really changing when we apply this new configuration? So this is actually a very interesting effect that we observe while analyzing the results of the optimization in the median latency here of the application response time. So you can see here a Dynatrace screenshot where we leverage this handy feature that lets you actually compare the performance of the application with respect to two different time frames, which corresponds to the baseline configuration, which is what you can see on the left, and the time frame based on that was related to a best configuration that we found looking at the results. consider the configuration that actually improved the performance the most. And what is very interesting is that you can see on the baseline configuration, this service was experiencing very high response time in terms of peaks. So it was actually not kind of slow overall, but actually was experiencing those high peaks. It had some kind of erratic behavior, which is not very good from a actual user experience perspective, and also from a site reliability perspective. It may be very close to breaching up SLOs, depending on other environment situation. And you can see actually on the right what we achieved. So some pretty significant and astonishing actually results. You can see how the application performance was stable, pretty much equal to the minimal service performance that the baseline had. So no peaks, no fluctuation whatsoever. So that was due to the best configuration that Akamas found by properly assigning the resources to the microservices. You can also see on the bottom what is the effect on the business transaction that Dynatrace is able to provide you. So in this case, you can see that also for some important checkout transaction, this was actually an e-commerce demo application. You can see that the new configuration actually sped up the application performance by more than 50% on some specific transaction, which were mostly impacted by the wrong configuration that we have, or the actually misconfiguration that we have at the beginning. Okay, so let's wrap up a little bit what we have seen here. So we have a couple of recommended resources that we would like to actually recommend you if you want to look deeper into that. So we have a couple of interesting sessions that Henrik already delivered on Kubernetes and SREs and observability, and also some other talks that we have already done at SREcon this year, where we have presented this approach for site reliability engineers, and also we have actually described the approach to optimizing Kubernetes performance in our blog post. One of the key questions that we always get at the end of webinars is, okay, that's a kind of revolutionary approach. How can we try that? So we really work it out to make Akamas actually enjoyable for performance engineers and DevOps and software site reliability engineers easily. So the easiest answer is that you can really join our free trial program. So it's very, very easy to actually try out the new AI-based optimization experience. It's just you just need basically a 3-step process where you can subscribe to our free trial in our website. Basically, we have prepared lots of quick start guides that lets you actually feel the power of AI-based optimization on sample applications, so that even if you don't have anything ready, you can really start and set up your environments quickly with a kind of step-by-step process. And really, in less than half an hour, you can start your first Kubernetes optimization study and really touch firsthand what we have talked about today. I guess that is it. Giuseppe, you wanna take the ball from there?
Yes, thank you, everyone. Thank you, Stefano and Henrik, for covering quite a lot of content on how to improve the observability of Kubernetes and optimize Kubernetes microservice application. Let me remind everyone that we have a question and answer chat window in the GoToWebinar control panel. In case you have any question. I know that we had received some questions from people registering. So one that I would like to pick, and I know we have backup slides for that, would be how does the Akamas and Dynatrace integration works? I think this is important as we pitch the message of the two solutions working together, but is there a real bidirectional integration? I'm not sure whether Stefano or Henrik, you want to cover this?
For the Dynatrace user, you simply have to go to our hub, which is showcase our integrations, and you will see all the wonderful materials that is available. But to answer the question, yes, it's a completely a bidirectional integration. So there are a few concepts that Stefano has explained. Of course, Dynatrace, in the case of the full stack optimization, would behave like a data source, because we have, like mentioned, all the various observability pillars that are been collected. So Akamas will interact with Dynatrace to retrieve metrics related to your services, your hosts, your processes, and will deliver that to the ML. So ML will decide how good we are with that current configuration. But the other thing is great to change all those settings, but it's really important that we keep track on the changes that has been done by the AI, because if you run 35 experience in 24 hours, then if you don't keep track on the history, it's going to be very difficult to understand what happened during that time frame. So that's why Akamas also push events back in Dynatrace, so then you can keep track on all the various changes that has been applied in your configuration. Stefano, do you have anything else to add on this?
No, I think it's a great answer. Yes.
Thank you.
We also
guys.
have Kubernetes matrix, of course, which we talked about before.
Yeah, of course.
I see another interesting question. Maybe this is for you, Stefano. Which Kubernetes parameter we target to optimize? That is a really great one for my perspective.
Yeah. Today, the most critical ones that we see as being, in a way, challenging for people to optimize is the one that we cover. So the whole topic of resource requests and limits for CPU and memory is something that people struggle with, but it's not the end of the story, because in Kubernetes you have lots and lots of configuration options that you can tune. Those are actually important to ensure service performance, reliability. There are other areas related, for example, to I guess we have a slide also on this one. Let me bring it up. Okay. Also on this chart actually shows the fact that Kubernetes pods and container is really actually the most important part to optimize, but you can actually go up in the stack and go down in the stack. So if we go up, it's interesting that we can also work on the runtime, and like the JVM or the Go runtime. Those kind of settings are very critical because they work hand in hand with the container settings. So if we change one, the other one may need revisiting for optimal performance. And we can also go considering higher and higher, consider also application level parameters. It's interesting that we also have other parameters within Kubernetes itself, which are interesting, like replicas, auto scaling. Those kind of settings are very important too. So at the Kubernetes level, and then it's in the cloud. It's also important to, in a way, go down below actually the application level parameters. We can also cover the infrastructural level layers, especially in the cloud. It's very easy, for example, to change the instance types and for example, choosing particular instance types on the cloud. Today on AWS, you have more than 200 instance types available. So which one is best for your workloads? Those are other kind of parameters and configuration options that you have at your disposal to really improve the cost efficiency. So it's really a full stack optimization game, I would say.
Stefano, I have another one, and I'll skip another, which I will come back later, but this one is kind of related. So what options for unknown Kubernetes panic, stress in terms of network bandwidth and resource utilization? I think this is a little bit tricky, but do we want to take it?
So the question is, what are the options?
Yeah, how to manage, I guess, for unknown Kubernetes panic, stress scenarios in terms of network bandwidth, resource utilization.
I would say that usually, usually there is no panic event. I mean, you have panic events, but you never improvise in production. So usually you already have done some few things on your testing environment. So those will be known behavior of your cluster or your nodes based on the test that you may have achieved. I think The idea is to understand then, and if you want to simulate or reapply a current behavior that you have seen in production, chaos
Exactly.
engineering could be a great approach, because you could force to generate more CPU usage on your node or on certain pods, or not drain a given node, or whatever it is, to simulate those behavior that you may have observed in your production environment or on the other environments, to validate that you will at least handle that critical situation and avoid impacting your business and your end users.
So I think we can say that prevention is the key here, right? Whether you are running chaos engineering or you're optimizing the environment to avoid the unexpected load, what you would put your system under stress or even make it unavailable. One other question, which I think, sorry, Henrik, but this is, can I use Akamas without Dynatrace, I guess? Do you have out-of-the-box open-source observability tools suggest as experts in performance monitoring and tuning? So yes, we work very well together, but Akamas can also work with other monitoring tools and telemetry options. Is that correct?
Yeah, exactly. We also support Prometheus as the open source option, which is very common.
And sometimes I know that we have customers that provide the ability for leveraging comma-separated value files, whatever would be the format they can make available, because in the end, the full process gets automated no matter what is the telemetry source that is available for the different environments. Good.
Yes.
I think we kind of answered all the questions. So just waiting one more minute in case there's any other question coming. Otherwise, I think we can close here. Thanks very much for attending. We will have additional events probably early next year. We're crafting the agenda for the upcoming events. Feel free to provide your suggestions. You can write to info@akamas.io. I think we have one slide with all the contact points. If you want to provide your feedback about the session, ideas for topics can be covered, feel free to write to us. And if you want to have a deep dive on any one of the topics we briefly touched today. But thank you again. Nice having you here. Let's talk again in the following webinars. Bye now.
Thank you. See you.
Thank
Bye.
you for your time. See you. Bye-bye.